Hello Year 9. This is the algebra section of the NAPLAN and it was a standard level, the very first video, and there'll be just 2 videos at the standard level. Even if you find this quite easy, please do it. It doesn't take long before you get to the intermediate level because it might give you a few hints. And I'll tell you what algebra involves. In algebra, we like to use the letters of the alphabet. For instance, this time we use K. It could be any letter. And K, we give it a value of 5. And what we want to do is find a value of 3K. In 3K, we substitute 5 for the K. And that would look something like this, equals to, oops, don't read it 35. Because in algebra, we need to now put the multiplication sign between 3 and K, or in this case 3 and 5, right between 3 and 5. Now that changes it. It's no longer 35, it's 3 times 5, and that means it's 15. And bingo, we have 15. So B is 15. In algebra, we also use patterns. And we get a pattern such as 1, 3, 7, 15 and 31. The first thing that I do is have a look at the pattern and see if visually there is anything that I can recognize. In this case, none of it makes sense to me. So the next thing that we usually do with patterns is to look at the difference between the numbers. And so I'll check what's the difference between 1 and 3. So the difference is 2. Now do the same thing for the others. And the difference between 7 and 3 is going to be 4. So that's 4. The difference between 15 and 7 is going to be 8. So we have 8. And the difference between 31 and 15 is going to be 16. So now we have another pattern that we can look at. Each number is twice the number before that. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and the next number that we'll need is 16 times 2, which is 32. So we need another 32 to add to this. By adding 32 to 31, which was our last number, and now we'll add that 32, we will get 63. That means our number now is 63. This problem shows another example of patterns. As each square increases by 2, you have to add 2 to it. 3 to 5 is also 2 plus 2. 5 to 7 we add another 2. 7 to 9 we add another 2, and so on. So that pattern is quite consistent. Now what about the circles? What's happening to the circles? 3 to 7 is a difference of 4, so we had to add a 4 to it. 7 to 11, we had to also add a 4. So what are we going to do from 11? Because the squares are consistent. For every increase on 2 in the squares, we're going to increase the circles by 4. So in that case, we will also need to add a 4. And if we do that, we will get a number called 15. And you can check that the next lot of numbers agree because 15 plus 9 is also adding a 4, and 19 plus 23 we're also adding a 4. And that was not a really hard problem here, but there will be harder ones, so stay tuned. The answer here is 15, so we'll circle 15. Remember, these are just the standard questions. Once again, we've got letters to designate numbers, and P here is meant to be 3, and Q here is meant to be 4. So what is the value of PQ? PQ, written like this, really means P multiplied by Q. So when we substitute 3 for P and multiply it by Q, which is 4, then we just get 12. So our answer to this is going to be B, 12. Again, a rule or a pattern question. That is, we double the previous number and add 3. And so the first number of our pattern is 1. Now we double the previous number, which is 1, so it's 1 plus 1, and we add 3. So our new number is 5. Now we'll double the 5 and add 3. So our new number is 5 plus 5 plus 3, which is 13. Now we do the same thing for the fourth number. We double 13 and again we add 3. So our fourth number is 29. And we write that in, 29. And here we have another pattern with a string of numbers, but this time there are decimals in here. So when I examine these numbers, I don't see any pattern in there. So what I'm going to have to do is find the difference in between each one. What's the difference between 2 and 2.6? And the difference is 0.6. And what is the difference between 2.6 and 3.2? Right, once again, if we take two numbers away from each other, we'll get 0.6. I can now see that there is a pattern in here. Each number differs by 0.6, and try the last one too, and that'll be 0.6. So by adding 0.6 to each number, we will get the next number. So in that case, what do we get for the next number after 4.4? We also need to add 0.6. Now we can do that, 4.4, and if we add to it 0.6, we will get 10.15. So our number is going to be 5.0. Since they had it in decimals, it's probably best to put the decimal point and a 0 after it. And another rule and pattern question. This time the rule for the number of pins, I'll just highlight, rule number of pins is equal to 6 times the number of octagons plus 2. How many pins are needed if the pattern has 12 octagons? Let's write out that rule first of all. So we have the number of pins, and that's equal to 6, which is then multiplied by number of octagons, and we add now to it 2. Well, that's the formula, that's the rule for this. So the question says, how many pins are needed if the pattern has 12 octagons? So this will be 6 times 12 octagons plus 2. So we work through this and say 6 times 12 is 72, and then we add 2, and that becomes 74 pins. So the number of pins that we want is 74. Now this rule is in terms of y and x. Y is equal to 4x plus 3. And we want to find the value of y when x is equal to 2. So what will y be if I substitute it in there for x? It will be 4 times 2 plus 3. That will be 8 plus 3, which is 11. And we can highlight A here for answer. And we need to find here which points lie in the shaded region, the blue region, and select all correct answers, which means that there will be more than one. This region over here, which I'm going to highlight in pink, has all the numbers negative. So the x values and the y values must be negative. And that means that we are looking at these are both negative, these are both negative, and that's it. But are they actually in the blue section? So let's go for the first one, is minus 1. Minus 1, we're going to the left, and then we must go 2 down, which is minus 2. And unfortunately in here it's not covered by the blue line, so that A cannot be true. I've just crossed it out. Now let's have a look at the second one. Minus 2, we're going minus 2 to the left and down to minus 1, and yes, this is going to be true. And I'll change it to pink to suggest that this is the one that we want. What about the C? We've got 2 and minus 1. 2 means we're going to the right, and then we must go down by 1, and that one is in the blue, so we can also circle it. Go to D. Minus 1, we're going to the left, and we're gonna go up by 2, and that's not in the shaded area, so that is not correct. I'm going to cross it out. Now I go to E, and I have 1 and 0. 1 means I'm going to the right by 1, and 0 means I'm not moving it up or down. So I am right there. That is in a white area. It's not in the blue area. That does not belong. So I need to cross this one out as well. Now the very last one, 0, 1. So I am standing right in the center, and I have to go up 1. So up there I am in the blue area. So this one can be highlighted. So far I've got 3 answers, and I have unfortunately colored some of them. So I'll just say that it's B is the answer, C is the answer, and F is the answer. To understand how to work these out, I suggest you think of a T as being a tiger. So 3 T's, we've got 3 tigers. And now I'm going to add 2 tigers. And now I'm going to add 4 tigers. So how many tigers do I have? 3 plus 2 is 5. 5 plus 4 is 9 tigers. And 9 tigers now becomes 9T. And now tomorrow I'll get the next video for you, more algebra. But in the meantime, please give me a thumbs up and make sure you've subscribed so that you can get that new video.